Welcome to this guide to the air release valve analysis and positioning calculator. Before we begin, it is important to emphasize that this tool is for indicative and educational purposes only. The results must always be verified by a specialized hydraulic engineer who will assess the specific conditions of your project. Now let's talk about the project data entry section. The first field is the operating flow rate expressed in cubic meters per hour, which represents the working flow rate. Below we find the pipe DN, which is the nominal diameter in millimeters, and the pipe material. Each material has a different roughness coefficient that affects head losses. The minimum negative pressure indicates the maximum allowable vacuum in the pipeline. The starting method allows you to choose whether the pipeline is fed by a tank at atmospheric pressure or by a pump with additional head. By clicking on the icon, the system updates the calculations. The source elevation indicates the elevation of the starting point in meters. The valve spacing defines the minimum and maximum interval within which to position the valves, preventing them from being too close or too far apart. The operating environment specifies the type of fluid transported: industry, seawater, treated water, sewage, or irrigation. The valve selection chooses the commercial family to use. Now let's talk about the profile entry section. Here we enter the nodes that define the pipeline route. For each node, we specify the progressive distance and the elevation in meters. The system automatically recognizes the type. Peak are the high points where air accumulates. Valley are the low points for drainage. Change are the slope changes. Now let's talk about the profile chart section. Here you can see the elevation profile of the pipeline. The color of the trace depends on the selected material, as indicated in the technical notes. The red hydraulic grade line represents the HGL with air pocket formation, therefore without air release valves. The green line represents the correct HGL, with the air release valves installed. Now let's talk about the valve refinement section. These controls optimize the automatic positioning. The first filter removes change valves when the head loss is negligible. The second removes peak valves when the evacuation velocity is already sufficient. Now let's talk about the gate valve section. Here we manage the drain valves at the low points. For each gate valve, we specify the diameter in millimeters and the discharge coefficient. By activating it, the system shows the adjacent valves, the water volume to drain, the estimated time, and the discharge flow rate. Now let's talk about the override by section. This section allows you to customize each individual section by modifying material, roughness coefficient, severity, and diameter. Changes are applied immediately. Now let's talk about the sequence table section. The complete table shows all nodes and sections. The node rows indicate position, elevation, and type. The pipe rows show length, slope, flow rate, and status. For nodes that require a valve, the Q burst is indicated. This value represents the water flow rate that would exit the pipeline in case of rupture, calculated based on slope, diameter, and pipe roughness. In practice, Q burst tells us how much air must enter through the air release valve to avoid dangerous vacuum during drainage. The recommended valve model to handle that flow rate is shown alongside. Now let's talk about the export section. We can generate a professional PDF report, export the chart in high definition, or download the data in Excel and CSV format for further processing. This concludes the overview of the calculator. Remember that the results must be verified by a qualified professional. Thank you for your attention and good luck with your work.